Hello everybody, welcome. Today I want to talk about Cartesian distance and midpoint. So get yourself something to write with because when you're thinking you should be writing. Thinking means connecting things and we need to have a good record of it. So let's switch over now to the screen. And let's talk about Cartesian distance and midpoint. What do we mean by Cartesian? Well, I'm talking about the kind of space system that Rene Descartes invented, which is basically two number lines at right angles to each other. You're commonly familiar with this X and Y grid space. That's Cartesian space. It's the Cartesian coordinate system. So what I'm going to ask here is this. How long is that line? Well, if it was just drawn on a sheet of paper, you could just measure it, right, with a ruler. But now in this space, what I'm really asking is, what's the distance between those two points? Well, it's not quite so easy then, or is it? Let's do this. Let me make a right triangle. Let me draw a bottom to this right triangle. This is going to be 8 units long, and let me draw a side to this right triangle. I think that's going to be 5 units long. And then what I'm asking for is this distance right here. So I've got a right angle right there, and so if you remember now the Pythagorean theorem says in a right triangle where C is the hypotenuse, C squared is equal to A squared plus B squared. Okay, here's the right angle, there's the side opposite it, so my C is now, I'm going to call that D for distance. That's really what I want to know. So D squared is equal to, what did I say, 8 squared plus 5 squared. Okay, so D squared then is equal to 64 plus 25. D squared then is equal to 89, and then if I take the square root of the left side and of the right side, I get my final answer. D is equal to the square root of 89. I don't think that reduces. Let's not do a decimal approximation. Let's leave that as an exact value. Okay, not too hard, was it? Okay, set up a right triangle, use the Pythagorean theorem, easy peasy. But now let's make a change. This was the distance between 2 points. Well, in Cartesian space, you can do an ordered pair to determine the location of points. So let's set this up with a Cartesian coordinate grid. And this is kind of arbitrary. It doesn't have to be this way, but I'm going to draw my y-axis right here. I'll let that be the y-axis. And then let this right here be the x-axis. Oops, that was supposed to stay a straight line. Let me try that again. There we go. So here's my origin right there. Okay, so now let's figure out what the ordered pairs are of these points. This is the first point, and that's going to be -1, 3. So there's my ordered pair. Now the second point is going to be 1, 2, 3, 4, 5, 6, 7. Way up here, 7, and then up. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay, so now I've got the location of those ordered pairs. Gee, how did I get 8 then along the bottom? Well, isn't 8 just the change in x? Have you seen delta for change? Delta, the triangle, just means change. So change in x. Well, what does that mean, change in x? Well, isn't that going to be the second x value minus the first x value? I think so. What's the second x value? 7 minus the first x value. Here's the 7 minus the first x value there in blue. Isn't that -1? What's 7 minus a -1? Isn't that 7 plus 1? And isn't that then how we got 8? Nice. Okay, so what I can do is this then. I can come back over here to the Pythagorean theorem, and instead of 8 squared, can I say this? Can I say that this is just going to be the change in x squared? Yeah? I think so. Now let's talk about the y's. So the 5 then, wasn't that the change in the y value, or delta y? Yes. Well, wasn't that the second y value minus the first y value? Yes, it was. And so then what was the second y value? Well, that was 8 minus the first y value way over there, which is 3. Isn't 8 minus 3 5? Yes, it is. So now I can come back over here. Instead of just 5, I can replace this with, well, that's just a change in the y. This is now us building a formula to use when that we can apply towards any 2 points on the Cartesian coordinate grid. So if I come down the next row, remove the numbers, and now replace it with what I've got, isn't this equal to, what is change in x? That was the second x value minus the first x value squared, and then plus, and then the second y value minus the first y value squared. And then here's what I do. Get down to the very end here. I can say that the distance then is equal to, if I square root both of those sides, this distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And right there, there's your formula to find the distance between any 2 points on the Cartesian coordinate grid, if you know their x and their y values. Okay, this is the distance formula. And let's run the numbers just to be on the safe side. We needed to get the square root of 89. All right, so here we go. I'm going to say distance is equal to the square root of, what was the second x there? The second x was 7 minus the first x, which was -1 squared, plus the second y value, which was 8, minus the first y value, which is 3 squared. And doesn't this give me that the distance is equal to the square root of 8 squared plus 5 squared? And isn't that what we started off with in the beginning? Yes, it is. Okay, so please commit this formula here to memory. This is the distance formula. But what was it based on? It's just the Pythagorean theorem. If you can remember the Pythagorean theorem, you can probably recreate the distance formula if you ever actually do forget what it is. Okay? Now, I want to talk about another property, and that's going to be the midpoint. Where is the middle on this line that we call D? Maybe do that in purple. Let's talk about midpoint here. Well, in going from point number 1 over here on the left to point number 2 over there on the right, and let me kind of erase these sorts of things here so we can get some kind of a clear picture without all the clutter. If I went 8 units left, no, I went 8 units right from the first point to the second point, wouldn't the middle be half of that? I think so. So let's try it. 1, 2, 3, 4. This is how far I'm going on the x. And if I went up 5, but I only want to go half of that, wouldn't that be up 1, 2.5 right here? And so if you look carefully, if I go to the line itself, right there, and then bring over on the y value right there, look, they point towards the same location. Okay, this point here, that would be the midpoint. So D would be the entire length of that, but now my midpoint I'm going to call M, capital M, and it's got a coordinate. Well, what is the coordinate there? It looks like it's going to be 3, and then up 1, 2, 3, 4, 5.5. There we go, that's the midpoint. How do you do this now algebraically? Well, a lot of textbooks call it the midpoint formula. It's not really a formula. A formula is what we have over here with like the distance formula, where you have an equal sign and you've got some equation stuff going on. The midpoint formula is not really a formula. The midpoint formula is just, I don't know if I have an easier way to say it. It's just the average of the x values and the average of the y values. Can you average two things together? Well, sure, just add them together, divide by 2, right? So let's add the x values together and divide by 2. What was the x value over there on point one, the first point? That would be -1. That's the first x value. What's the second x value? Add it together. 7. And then divide that by 2. What is that? -1 plus 7, 6 over 2. That's 3. Okay. Now let's do the average of the y values. What was the first y value? And in the order here doesn't make any difference. 3. Come on, pen. 3 plus the second y value, which was 8 divided by 2. Just find the average of the y values. What's that? 11 divided by 2. What's that? 5.5. Voila! There's your ordered pair of the midpoint. 3. 5.5. So your midpoint formula is nothing other than the average of the x values and the y values. So I'm going to say midpoint, it's an ordered pair. So it's going to be x1 plus x2 over 2, just the average of the x's, add them up, divide by 2, comma, y1 plus y2 all over 2, and there you go. Okay, so you should have that committed to memory too, but like, don't be a slave to just memorizing a mindless formula or a mindless expression. Just understand what it means. It's just the average of the x values and the average of the y values. And the distance formula is just the Pythagorean theorem. Okay, all right, so now let's do some practice problems. Let's try, if I can get the iPad to work. There we go. All right, so let's try it now analytically. Let's try practice problem number 1. We'll do example number 1. Let's find the distance between 2 points, -9, -8, and the point -7, 8. And so if you've got the video rolling and your pencil and paper handy, go ahead and press pause on the video and use the distance formula and see if you get the same answer I do. So go ahead and press pause. Give it a shot. And hopefully you've done that. Let me show you what I'm going to do. First of all, every time I use a formula, I'm going to write it down. So I'm going to say that the distance then is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to plug my values in. Distance is equal to the square root of second x value, -7, minus the first x value, -9. So that means change to a +9 squared. Then plus second y value, 8 minus the first y value, -8, so they become added squared. Okay, so now distance is equal to the square root of -7 plus 9 squared. Isn't that going to be then 2 squared plus 16 squared? Okay, so distance is now equal to the square root of 4 plus, oh my goodness, I'm embarrassed, I don't know what 16 squared is. 15 squared is 225, 16 squared, 256. So distance is now equal to the square root of 260. Does that simplify? Well, what's the largest perfect square that's a factor of 260? Let's try 4. 260 divided by 4. I think that's divisible by 4, isn't it? Yeah. So this is equal, then I'm going to go sideways here in the interest of space. This is equal to the square root of 4 times 64. No. 4 times 260 divided by 4. 65. There we go. I knew that didn't feel right. And the 4 comes out as a 2. So the final answer then, 2 square root of 65. There we go. How'd you do? Okay, good. You might even do it at this point. To write the formula down, you might even call it the square root of the change in x squared plus the change in y squared. That may be a faster version for you. Okay. So that's example number 1. Example number 2. Whoops, we'll come back to that one in a second. I thought that was lower on the screen. Example number 2. Midpoint is so easy, I'm not even going to bother asking you the midpoint between two things, because all you have to do is average them, and that's a 5th or a 6th grade skill. Let's do this. What if I tell you that there's a line segment AB, and A has a point of negative 5, 7, and M is the midpoint of that line segment, and the midpoint is negative 1, 4. And what I want to know is, what are the coordinates of B? So instead of giving you the 2 endpoints and asking you for the midpoint, I've given you 1 endpoint and 1 midpoint, and then asked you now for the other endpoint. Well, my advice is to break this down into 2 separate problems. One of them is the x's, and one of them is the y's. So we know that the midpoint value of the x's is going to be x2 minus x1 over 2. That's equal to the x midpoint, right? Subscript m for the midpoint of the x. So what does this mean? Well, I don't know the second point, so let me leave that as an x. X minus the first x point, isn't that positive 5 or negative 5? So x plus 5 all over 2. That has to equal to the midpoint. What's the midpoint of the x, negative 1? Do you see what I've done? I found the average of negative 1. The average is negative 1, and the beginning point is 5. What's the second thing that gives you the average of negative 1? It's a very simple equation. Okay, I'm just going backwards to find x1. Or x2 as it were. So now, solve this for x. Well, I'm going to multiply both sides by 2. So x plus 5 is equal to negative 2, and then I just solve that for x by subtracting 5. X is equal to negative 7, so negative 7 goes in there. And negative 7 plus negative 5, negative 1. That doesn't feel right. Where's the error? I'll see if I can sort this out. Something's not right on this one. I found it. This is embarrassing. But it's good, because this mistake is what students do. All right, here we go. You caught a sight into Mr. Marsh's math trouble from time to time. Here we go. This is wrong right here. Remember, it's the average. Shouldn't that be a plus in the middle? Why in the world did I make it a negative? I know why. The distance formula's got negatives in it. And these two principles are always done together, like in the same lesson. Maybe we should split them out into 2 different things. On one of them, you subtract them. On the distance formula, you subtract the x's and the y's. On the midpoint formula, or if you want to call it that, on the midpoint thing, you're adding them, and you got to keep them straight. Rats. I haven't done that in a while, but I knew it didn't feel right. Like, okay, so here's the deal. When you make a math mistake, Don't quit and start over. Don't erase your work. Your job's to go back and find it and resolve it in your mind and fix it. I could have pressed, pause on the video and said, I got to reshoot that. Can't have Mr. Marsh making a math mistake in front of the students. No, I found it, right? Go back and find it. Imitate me, not in making the mistakes on purpose, but in going back and finding it then when you make a mistake. All right, let's see if we can go back and fix this now. Because obviously the halfway point between -5 and -7 is not -1. So this will come back in through here. This will then make that a minus. And so then that changes this to a minus in there. And so then I'm going to add 5 to both sides. And so that I think is going to be a +3. So change that over there. +3. And just for giggles, is 3 plus a -5 divided by 2, is that equal to -1? Yeah, okay, there we go. The averaging works now. Okay, so now do the same thing for the y values. See if I can get it all in view here. It's going to be, not x, see now I'm in a kerfuffle. So now y2 plus y1 over 2 is equal to the midpoint of the y's. So what's the second y value? I don't know. We'll leave that as the variable. Plus the first y value, that's 7, all divided by 2. That has to equal the mid of the y's, which is 4. Okay, so now multiply both sides by 2. I get y plus 7 is equal to 8, and then -1, -1, and whoops, -7, -7. I was thinking of the answer. Y is equal to +1, so here we go. There's my midpoint there. I'm sorry, there's my ending point B. Ending point B, 3 and 1. And let's just double check again. Is 7, the y's, plus 1, all divided by 2, is that equal to 4? Is the average of the y values 4? Yes, because that's what it is. The midpoint is the average of those two things. Alrighty? Woo! We got time to do this last one here? Yeah, let's do this last one here. Clear that off. Alright, so circle R has a diameter ST with endpoints of S at that location and T at that location. What's the circumference and the area of the circle? Express your answer in terms of pi. Well, this is a geometry problem, and the very first thing that I would like to do is maybe even see the space. So, I don't know. Let me do kind of like just a little sketch here. This isn't going to be the scale, so don't get too upset if they're off. 4 and 5, that's going to be a point maybe somewhere like over here, something like that in quadrant 1. -2, -3. -2, -3 is going to be in quadrant number 3, and maybe this one right here. So we got some kind of circle in there. What is the circumference in the area? Here's what I'm asking for: circumference and the area. So the circumference is one thing, the area then is something else. Remember the formula for the circumference of a circle? 2 pi r, or circumference is equal to pi times the diameter. Well, what's the diameter? It's the distance from here to here. Oh, the distance! Hey, if I can find the distance between those 2 points, S over here and T over here, then I can just multiply by pi. All right, so distance is equal to the change in y squared plus the change in x squared. Notice I switched those, y first, and then x. Is that okay? Yes, when you're adding them. So what is this then? Distance is equal to, what's the change in the y values? If I go from 5 and I stop at -3, isn't that a change of -8? It is. And what about the x's? If I go from 4 and I stop at -2, isn't that a change of -6? Yes, it is. Square both of those. And if you want to substitute the points in for the formula, that's fine too. So distance then is equal to the square root of 64 plus 36. What's that's 90? That's distance is, oh nice. Distance is the square root of 100. Distance is equal to 10. There's my answer. No. I was asked to find the circumference. Okay, don't forget you're asked to find the circumference. The circumference is equal to pi times the diameter, so 10 pi. And there we go. We've left our answer in terms of pi. Okay, now the area. Area is going to be pi r squared. So what's the radius? Now you could do this two different ways on the radius. You could do some work to find the midpoint of this line segment somewhere in the middle there, and then you could find the distance out to one end, right? But isn't the radius just half the diameter? If I already know the diameter is 10, what's the radius? So the area is equal to pi times 5 squared. So the area then is equal to 25 pi units squared. There we go. For these geometry problems, it would be best if you made like a little sketch and thought about what you needed geometrically, a distance here or a radius there, and whether it's a diameter or something like that, and that'll sort itself out. Whew, kind of rocky there on that lesson for a bit. Got my heart rate going up. I'm like, oh, I'm embarrassed. But no, it's good to be able to go back and find your mistakes. And that's one of the chief benefits of studying mathematics. The truths of mathematics can be demonstrated. And you're going to make mistakes all through life. Wouldn't it be great if you had a method that you could go back and find it and then know for certain that you've corrected it afterwards? That would be nice. Okay. So let's pursue goodness, truth, and beauty and not be dissuaded or held back by setbacks or failures at a certain point. Pick yourself up and go on. Anyway, hope you have a great day. Bye-bye.